Hi there, my name is Raoni Boaventura, and my objective with this course is to introduce you to the AngularJS framework and how to develop single-page web applications using it. Before anything else, let's start with the basics. What is AngularJS? AngularJS is a JavaScript framework created and curated by Google to help you to build well-structured and easily maintainable single-page web applications. If you're not familiar with the technical jargon, let me break this up for you. As I mentioned, AngularJS is a JavaScript framework. A framework is a reusable software platform meant to bring together all the components you need to develop a specific kind of application. A framework implies that instead of writing your application code however you want, you adopt the standards set by the framework and structure your application in a specific way in order to take advantage of the framework features. In AngularJS case, those features include a flexible template engine, two-way data binding, amazing testability, and much more. Now, what is a single-page web application or SPA? Well, it basically means your application, regardless of size, will be loaded by your browser as a single page. When you navigate throughout your app, instead of actually loading new pages, your application will load only the content from the server and display it on demand. From the final user perspective, a single-page web application works no different from a regular application. From the developer perspective, however, there's a huge difference. Let's check out an example. Here, there is a movie database application written in AngularJS. Note that we can move back and forth between different pages, just like a regular application. In this case, however, no page reload is actually being performed by the browser. What is really happening here is that when you click a link, AngularJS requests the information it is going to need for the page directly from the server and take care of showing it using the right HTML template. All of that happens in the user computer. That is very distinct from the classical approach, where the browser would load a new page on each click and the server would be responsible for fetching the information, rendering the right template, and serving the final page back to the browser. Another key feature of AngularJS is its testability. The framework comes bundled with every tool you're going to need to write automated tests and to perform test-driven development. If you're not familiar with those concepts, don't worry. The last section of this course is entirely dedicated to this topic. The main objective of this course is to jump straight into action and learn how to use the features of AngularJS by example. The main goals expected to be achieved in this process are the following. First, learn the basics of the AngularJS framework. What are the advantages and the restrictions involved, and what kind of project it suits better. Then, learn how to write and debug AngularJS simple applications, including the movie database application we just saw, and how to integrate those applications with any server-side technology of your choice. Finally, we'll review the basics of how to write automated tests and practice proper test-driven development, using the tools available within the framework. With no more to say, let's jump into it. Before we can jump into the course, there are a few concepts I must assume you're familiar with. The first being the basics of JavaScript programming. AngularJS is written in JavaScript, so if you never had any contact with the language, this is probably not a good place to start. Second, you need to have some basic understanding of HTML and CSS, and preferably have some experience building web applications with it. AngularJS is a front-end framework in the end, so we're going to be using a lot of markup in our templates. Then, you're gonna need a text editor. If you already have a preferred text editor, like Vim or Emacs or whatever floats your boat, you can stick with it. My current editor, however, and the one I'm going to be using on this course, is Sublime Text. It's robust, works on every platform, and you can try it for free if you want. Finally, the last two things you're gonna need before moving on are Git and Node.js. No, don't worry, you don't need to actually have any experience with those tools, but you do need to have them installed on your computer in order to follow this course. Git is a version control software. If you don't have Git yet, you can find it on Git's homepage, alongside instructions to install it on your platform, being it Windows, Linux, or Mac OS. Alternatively, if you are on a Windows or Mac, you can install the GitHub desktop application that will automatically install Git for you and also provide a decent guided user interface to manage your repositories. You can find the Windows version on windows.github.com and the Mac version on mac.github.com. Finally, you will need to install Node.js. Node.js is a JavaScript runtime environment, and you are going to need it in order to run, debug, and test your application. You can find it on nodejs.org alongside instructions to install it on your preferred platform. Now that you have both installed, you're ready to start. Let's get to it. Now that we're all set, let's start introducing the intrinsic concepts you need to know before going into AngularJS. First of all, AngularJS is a very powerful templating tool that changes the way HTML works, making it more powerful. According to the framework creators, HTML is great for declaring static documents, but it falters when we try to use it for declaring dynamic views in web applications. AngularJS lets you extend the HTML vocabulary for your application. But what does that mean exactly? Well, to start, let's take a look for the first time at what an AngularJS application code looks like. This is a very basic application I call Player Database. It doesn't do much. It's just a list of football players with a simple keyword search input that allows me to filter it. If you want to take a look for yourself, you can find the code for this app among the complementary files provided for this course. And here's what the template of the list you just saw looks like. At first, it looks like some standard HTML. Here in the top, we have our CSS imports as usual. In the bottom, we have some script tags including the AngularJS library and some of the application JavaScript files we're going to talk about in a minute. And here, in the middle section, we have the template for the player list you just saw. If you pay close attention, however, you're gonna notice the presence of a few elements you wouldn't see in your standard HTML. First, we have some sections of the code here between curly brackets we use to return variable values. These are called expressions. In AngularJS, expressions allow you to execute some computation in order to return a desired value. Some valid expressions would be 1 plus 1, that will print 2. This one will print this Unix timestamp in a date format, and the last one will print the value stored in the variable user.name. After the expressions, the second thing you will notice is the presence of a few attributes here, starting with the ng letters, like ng app and ng controller. Those attributes are called directives. AngularJS extends HTML functionality by providing directives that add behavior to your markup and allow you to create powerful dynamic templates. In other words, when you're using Angular, your HTML gains superpowers. You can even create your own directives and further extend your markup for any purpose you need. However, that's not the only superpower AngularJS provides to your templates. Another feature Angular provides that will make your template so sweet is two-way data binding. Basically, AngularJS completely changes the way data is represented through HTML. For example, in standard JavaScript, if you print the value of a variable on screen, and then later you update the value of that same variable in memory, this will not affect your HTML. That's because your HTML is static, and if you want to show the new value on screen, you need to either manually or procedurally update the value in the HTML. In AngularJS, the template engine works in a different way. Basically, if you choose to print a variable, like we're doing here, and you later change the value of that variable in memory, HTML is immediately updated to represent the new value of that variable. No need for event handling or DOM manipulation, it just works. This behavior is called binding. You're not just printing a variable value here, you're binding the variable to the template, and any changes on your variable will be reflected on it automatically. The reason it is called two-way data binding is because the binding works both ways. The same way it automatically updates your templates, it also updates your values in memory. For example, here we're using the ng model directive to bind the value of the search filter variable to the input we see here. If we update the value of the variable in memory, the input also gets updated. But if we enter a value directly in the input, the value in memory is also updated. And that change is going to be reflected in any other elements binded to the same variable. In this case, the filter of the list we're showing is binded to that same variable, so updating the input also updates the filtering of the list. Speaking of filters, Angular has a filtering language, so you can easily specify ways to organize or change the way your data is displayed on the template. For example, if you have a date in Unix format that you want to display on your view as a day, month, year format, you would apply a filter for that, so you can show your variable value in a different way of the one that is represented in memory without having to sacrifice the two-ways data binding. Like the directives, you can also create your own custom filters. Now that you're familiar with those templating concepts, let's move our eyes from the HTML for a second and take a look at the structure of our application. First of all, AngularJS makes use of the MVC architecture. MVC stands for Model, View, Controller, and it basically dictates that we divide our application into 3 separate layers. The model, in a front-end MVC context, is basically your data. In this case, our model is the list containing the information about the players, and we're defining it inside of our app for convenience. But this information could be retrieved from a relational database, from a JSON file, from a server API. Basically, your model is the data that you want to show or manipulate, despite where it comes from. The view is basically your templates. It's the markup responsible for showing the information you want on screen. In our example application, the whole view is contained in the index.html file. In more complex applications, however, the views will be usually broken into smaller pieces or partial views. Finally, the controller is the JavaScript that ties the model and the views together. Every template or view is bound to a controller and will only have access to the information available in the scope of that controller. In our application example, there is a single view and a single controller. The model is defined inside of the controller as a static list of players as we see here, and then is binded to the scope variable so it's available in. Now, there is one last piece of JavaScript that ties our application together here, and it's in the app.js file. In this file, we actually initialize our app and invoke the controller. We named our app ListApp, and we create it using the Angular module function that creates a module for us that contains our app. But what is a module in AngularJS? You can think of a module as a container for the different parts of your app. Controllers, filters, directive, everything can be contained in a module, including the application itself. Modules can also depend on other modules, meaning that in order to load your module, you need to first load its dependencies. Let's take another look into app.js. Every time you create a module, you need to provide a name and an array of dependencies. The array of dependencies contain all the other modules that the module you are trying to create depends to work. In this case, we are creating a module called ListApp that depends on a second module called ListApp.controllers. And the ListApp.controllers module was defined in our controllers.js, and it has our application controller registered into it. By registering ListApp.controllers as a dependency into our ListApp module, you're basically telling AngularJS dependency injection engine that it needs to load the control module first, and then the app module. This is how AngularJS deals with dependencies. Okay, now that we tackled at least some of the basic concepts, we're ready to start writing your first application. I know, that's a lot of stuff, but don't panic. Of course, during this course, we're going to revisit each one of these concepts in depth, and by the time you're done with it, you'll be perfectly comfortable with each one of these. Hi. Now that you're familiar with the terminology of AngularJS, it's time to start coding your first application. To help us on this task, we're going to use a boilerplate called Angular Seed. A boilerplate is nothing more than a reusable application skeleton. It will not only create your project folder for you and supply a blank application to give you a place to start, but also provide you all the tools you're going to need to manage, run, and test your application. You can find the official Angular Seed project on github.com/angular/angular-seed. That's the official Angular boilerplate, developed by the Angular team, but it's not the only one available out there. For enterprise applications and large-scale projects, you will probably want to find a boilerplate that better suits your project. But for the purpose of this course, the official one will do just fine. To download Angular Seed, you will need to copy the clone URL from here and then go into your command prompt if you're on Windows, or to your terminal if you are on Linux or Mac OS. Navigate to the folder where you want to create your project. In this case, I'll create it in my user folder. Let's create a new directory called AngularJS. Let's navigate into this directory and let's do a git clone and paste the clone URL. This will clone or copy the entire project to your hard drive. This may take a minute, but alternatively, you can either download the project as a zip file from here, or you can clone it using the desktop application if you installed it. Now that Git is done downloading the project, let's navigate into the directory just created and then run the command npm install. npm stands for Node Package Manager, and it's the whole reason you install Node.js in the first place. What this command will do is to download and install all the programs and libraries you are going to need in order to manage, run, and test your Angular application. This process may take forever, especially if that's the first time you're doing it, since there's a lot of stuff to install. In the meantime, let's switch to Sublime and take a look at the folder structure of the project. Okay, so that's what your application file structure looks like right now. First, we have an app folder to contain the files of our application. We have an E2E tests folder that contains the specifications for the end-to-end tests. We're gonna get to that later. And then we have a few configuration files that you don't really have to care about right now. Inside the app folder, we have the important files of our application. First, you have the index.html. This is the main file of your application, and it's where all the other files will be loaded from. Alternatively, we have index-async.html. That is basically the same file, but configured to load the AngularJS framework asynchronously. We're not gonna use it right now. Then we have the app.js file. Here is where you initialize your app and configure the routes of your application. Moving on, we have the app.css file that contains your application CSS. Then we have a few extra folders. The view1 and view2 folders you're seeing here are two example views that are pre-configured in the Angular Seed project. Each view contains three files. The v1.html is the template of the view, the v1.js is the controller of the view, and the v1test.js is the unit test suite for your controller. You're supposed to create as many directories as views of your application. We're gonna get to that later. Finally, we have the components folder that is supposed to contain the other components of your app, like filters, directives, factories, and service. The Angular Seed project comes pre-configured with an example component called version that contains an interpolate filter, a version directive, and a version module. Each one of these files has a correspondent unit test files associated to it with the same name followed by _test. As we run through the course, we're gonna be familiar with each one of these components. The important part right now is to understand where you can find each file. Without losing too much time on details right now, let's take a look on how to run your application. Once npm is done installing, go back to your terminal and enter the command npm start. This will install the last components you need to run your application, and then will initialize a local server for you and you'll be able to see your app in action. Now go back to your browser, go to localhost 8000/app, and there you go. The Angular Seed app is now up and running. In the next video, we're gonna learn how to go on and build our own application from here. See you there. Hey guys, welcome back. In the last video, we've learned about the Angular Seed boilerplate and how to bootstrap and run our application. Now it's time to actually start coding it. But first things first. Last video, we saw that Angular Seed provides you with an example application structure. But we don't want to use any of that right now, so let's start by cleaning up this code and starting our application from scratch. Let's open the index.html and remove all its contents. We can also remove the index.async.html file since we're not going to be using it this time. Now let's go to the app.js and clear what we find there. I'll just leave the use strict command here so we have our JavaScript running in strict mode at all times. Then you're gonna get the view1 and view2 folders and delete them. Usually those folders would be used to hold your partial views and their respective controllers. But in this first example, we're gonna have a single controller and a single view. So let's create a new file called controllers.js that will contain our application controller. Now if we load our app again, nothing shows up, of course. So let's head back to index.html and start coding. The index.html file is the heart and the main file of our application. So let's start with the basic HTML code. First, let's add an HTML tag, a language English, and then a head and a body. In the head, let's add the character set and a title for the page. Let's call it to-do list app, and then a link to our style sheet that is located in app.css. By the way, if you check out the app.css file, you also find some leftovers here. So let's remove those and go back to the index. Now in the bottom of our body, let's include our JavaScript files. First, let's include AngularJS that is located in bower components /angular/angular.js. Then let's also add our app.js file and our controllers.js file. Now let's go to the app.js file and actually initialize our application in AngularJS. We're gonna do that using the angular.module function. That function creates a module and it gets two parameters, the name of the module and the dependency array that lists all the dependencies of the module. We called our module to-do-app, which is the name of our application, and we're gonna add to-do-app.controller to the dependency array. But we don't have the controller yet, so let's go to the controllers.js file. In the controllers.js file, we're going to register a new module called to-do-app.controllers that has no dependencies, and within that module you're going to register a controller using the controller method. The controller method gets two parameters, the name of the controller and an array containing the dependencies of the controller and the controller method itself. In this case, we're going to register as a dependency an AngularJS object called $scope or the scope variable. The scope variable is one of the most important objects in your controller. The scope object is basically responsible for providing the context against which expressions are evaluated. In other words, it makes the bridge between your views and controllers. Any object that you register inside of the scope object will be directly accessible in your view. For example, let's register a variable called scope.helloworld and assign it some value. Now the hello world object will be directly accessible in your view. You can print its value by accessing index.html and invoking it as an expression like this. But before I can show you the value being printed, there are a couple directives we're going to need to add to the body tag in order to wire up our application. We're going to use the ng-app directive and assign our app name to it, and we're going to add the ng-controller directive and assign to it the name of our controller module. And now you can check our application in the browser if you have the server running. Refresh the page and here it is. The variable name assigned in the controller made its way into the view. But getting back to index.html, what exactly I did by adding the ng-app and ng-controller directives? The ng-app directive designates the root element of the application and is typically placed near the root element of the page, like the body or HTML tags. Basically, it tells AngularJS where your application starts and finishes. The ng-controller directive tells AngularJS which controller is in charge of your view. Since our application has a single controller for a single view, we can place it right beside the ng app directive. Now let's try to do a little different. Let's get back to controllers.js and rename our variable new task and assign any value to it. And then in your index.html, instead of printing the variable, we're gonna add an input and we're gonna use the directive ngModel to bind the variable new task to the input. Now the value of new task is binded to the value of HTML input. If I choose to print the variable right below it, and then we go into the browser, you can see that the value in the input and the value being printed are bound to each other, thanks to two-way data binding again. In the next video, we're going to continue from that point and turn this scaffold into a real application. I'll see you guys there. Hey guys, welcome again. In this video, we're going to take on from the point where we stopped last time and create a task list for our to-do application. First, let's go back into our controller.js, then let's create a new array in our scope called task list. Then let's add an object to that array, a hash containing two properties, description and a boolean called done to check if our to-do is already done or not. And let's make it 3 instead of 1. Make auto reservations. Okay. This will be our mock model, the list containing all the tasks we gotta do. Now let's go back to index.html and actually print that list. Let's organize things a bit and create a div here with the ID task list and a second one to contain the ng repeat directive. The ng repeat directive is one of the most commonly used and serves to define your template when looping through collections. In this case, we're trying to loop through the task list object. So let's assign ng repeat task in task list. Then we're going to create a little template of how each task should be printed. Let's create it like a label and let's add the description, and let's also add an input, a checkbox that is tied to the task done value, and let's make it using the ngModel directive again. This way the value of the checkbox will be binded to the value of the boolean. Now if you go back to the browser and reload, you can see your list. The ng repeat directive created a copy of the template for each element of the list. Going back to our controllers.js, it's time to add some functionality to it. First of all, we want to be able to add new items to our list. So let's create a new object on the scope called addToDo, and let's assign a function to it. And what this function is going to do is first get scope task list and push a new element to it. This element will be a task. The description will be the value stored in the scope new task variable, which is the same that we binded to the input in the view, and the done will be just set to false. Then we are going to reset the value of the input doing this. Now let's go to the index.html and upgrade the input a little bit. First, we're gonna add a button alongside the text input to be our submit. Let's call it add task. Then we're gonna put these two elements into a div and put it all into a form. And this form will get the directive ng submit equals addToDo. This directive tells Angular that whenever the form is submitted, it is supposed to execute the addToDo function. Now let's give the application a headline like what needs to be done. And when you get back to our browser, you can see it works. Now you can add as many tasks as you like. But how do you proceed to remove them? Well, let's go back to our index.html and add a delete button. Let's call that button delete, and let's use a directive here called ngClick and bind this directive to the function delete_to_do index. The ngClick directive tells Angular that whenever the button is clicked, the delete_to_do function must be triggered. And the $index variable we're passing here is going to return the index of the current object in the array being accessed by the ng repeat. The first element on the array will have index 0, the second will have index 1, and so on. Now let's go back to the controller one more time and add the delete to do function. This function is going to take an index as parameter, and it's going to access the scope task list array and eliminate the index element using the splice method. Now go back to the browser and check it out. We can add tasks and we can delete tasks. Now let's do one more trick. Go back into the index.html, go to the label class description, and let's add one more directive, the ng class directive. And let's pass to it as parameter strike task.done. What this directive is doing is telling Angular to add one more class to the label called strike in case task done, the expression in the right, returns true. Now let's go to the app.css file and add some styles to it. Let's call it id test list dot strike test decoration line true. And as simple as that, now you can go back to the browser and check it out. When you mark a task as done, the text is crossed. When you unmark, the text is uncrossed. In the next video, we're going to go on improving this application until we have a fully functional and nice looking task list. Hello again, guys! Moving on from where we last stopped, our to-do application is almost functional now, but it could definitely make use of some CSS. Let's take that chance to take a look at how to deal with CSS frameworks in AngularJS. For this example, we're going to be using the Bootstrap framework. Bootstrap is a CSS framework created by Twitter guys to help you building organized, beautiful and responsive websites. If you're not familiar with Bootstrap or CSS frameworks in general, don't worry about it. Let's check step by step how to include it and how to use it into our project. First, let's get Bootstrap CSS and include it to our app. You can get the official Bootstrap code on getbootstrap.com. But to spice things up a little bit, let's download a colorful Bootstrap theme instead of using the vanilla flat Bootstrap appearance. First, go to bootswatch.com or any other template site that you like and choose your favorite template flavor. I like the Amelia color scheme here. So let's get the CSS file and save it into our projects folder. I could get the minified version of the CSS instead if I wanted to deploy to a production environment, but since that's just an exercise, let's go with the full version. After adding the CSS file, let's open our index.html and add an extra line to import the file into the project. Now, the framework CSS is already on your project. But there are a few additions we'll have to do in our code in order to take advantage of it. First, let's add the container class to the body so we can make use of a fluid grid. Then, let's add a new div and let's class a row fluid and add everything we already have into it. Now your application will not extend over the width of the page in any circumstance. Next, let's add an extra div and set a class with the column width and another one with the offset width, so we can centralize our content in the page. Then, we want our form to stand out a little bit, so let's add a new div with the Jumbotron class, which is Bootstrap class for the main banners and header content. And then let's add some classes to the text input and to the add task button so they look more classy. It already looks less terrible. Now let's merge the input and the button using a little Bootstrap trick called input group. First, we create the input group container around the inputs, and then we add a span called input group btn, and we add our button to it. Go back to our view, and it looks way better now. Now, to prettify the task list, let's make it into a list group. For that, we only need to add the list group class to the container and the list group item class to the ngRepeat div. Let's add an extra couple classes to the delete button to make it look more fancy, and then, yeah, it looks a little better, but it still lacks a few adjustments. Let's go into our app.css file. First, let's take care of the task descriptions. The Bootstrap theme we included makes use of a Google font called Lobster. So let's make using that font into our description. Let's add font family Lobster. Let's add some other attributes like font size and remove the margin and make the cursor a pointer. Then let's take care of the checkbox, just simply adding a little margin to its right. And last, let's place the delete button in the right and set its spacing. Take a look to the browser, and it looks considerably better now. But there's still a little trick we want to do, so let's go back to the CSS and make the delete button invisible by adding visibility hidden. Then let's make it visible only when you mouse over the group item. So let's add list group item hover button visible. Also, we want the group item to stand out when you hover it. So let's add a background color and let's check again our browser. That is way better than before. On a side note about Bootstrap, we've only imported the framework CSS here, but if you want to make use of the framework JavaScript components, there's an awesome project called UI Bootstrap that you may want to take a look at. The UI Bootstrap project is an implementation of all Bootstrap JavaScript components as AngularJS directives. This way, you can use all of the Bootstrap components without having to add jQuery or bootstrap.js to your project. I'm not going into details about it right now, but always consider including it when working with Bootstrap. In the next video, we're going to check out how to expand the capabilities of our application and add a few animations to it. Hey guys, time to give the final touches to our application. Last time, we added Bootstrap and made our application more presentable. Now, let's add some more functionality to our task list. First, what about keeping track of how many tasks were already marked as done and how many are still not checked? To do that, let's go back to our controller.js and add a new variable called pending count that will represent the amount of tasks that still have to be marked as done. Let's assign 3 to it since our mock task array starts up with 3 tasks. Then, let's make use of the watch method of the scope object. The watch method basically keeps an eye on any scope object or variable you pass as parameter, and it executes some function when this object suffers any alteration. The first parameter will be the name of the object you want to keep an eye on, the second will be the callback function, and the third is just a boolean indicate the type of comparison the watch method is supposed to make. Let's pass it as true so Angular will know the object must be compared by content and not by reference. Now, for the function, we're going to make use of a new AngularJS object called $filter. The filter object allows you to use filters inside of the controller, so let's add it to our controller dependency array and then add it to this line. What we're doing here is, every time the task list array suffers an alteration, the watch method will update the value of the pending count variable with the length of the array that only contain the tasks that are not yet done. Now let's go back to our view and let's show that variable somewhere. First, we create a new span and then we add the expression to it. Check out the browser and you see it already works. But we can make it a little better. Let's go back to the view, delete the items left and replace it with the ng pluralize directive. The ng pluralize directive is very intuitive. It basically keeps an eye on a variable and print the suffix depending on the value of the variable. In this case, we print item left for 1 and items left for any other value. Go back to the browser and check it out. Okay, now what about adding a button that clears from the list all the tasks that were already marked as done? First, let's go to controllers.js and add a function that clears the task marked as done from the array. Let's call the function clearComplete and let's make it using the filter object again. This time, we're going to replace the value of the task list with the array returned by the filter object after we filter out all the tasks marked as done. This should do the job. Finally, we have to add the clearCompleted button to the view. Let's go back to index.html and add a button alongside the items left. Let's call it clearTasks and let's bind it to the clearCompleted function using the ng directive we used before. Finally, let's add some Bootstrap classes to make it standard and let's add a name to it. We'll show the text clearCompleted and then the count of the tasks that will be removed, which is basically the sum of tasks minus the ones that are still pending. Finally, Let's go for app.css and align the button on the right side of the screen. Now go back to the browser and check it out. It works. To make it just a bit more fancy, let's go back to the index.html and add a new directive to the button. The ngShow directive will hide the element in case the expression provided to it as a parameter is not true. In this case, we're comparing to see if the pending count is smaller than the whole task list. In other words, the button will only show up in case there is something to remove using it. Now go back to the view and test it again. Great, right? Now let's try something different. What about adding some animation to the transitions of your template? To do that, we're going to need the Angular Animate module, or ng-animate. The Angular Animate module is not part of the AngularJS basic module, so we need to download the module and add it to our app. Let's take that chance to learn how to add new modules in Angular. I will show you two distinct ways to do that. The first option is to do it manually. You can go directly in angularjs.org page, click download, browse the extra modules, and add it to your project folder. Then add a link to it on your index.html file, and it's done. The other way, and better way, would be to import the module using Bower. Bower is a JavaScript package manager and it already comes bundled with the Angular seed boilerplate, so you already have it in your project. Remember the files on the root of your project? There is one among them that is called bower.json. Bower.json contains a list of all the external modules your application needs to include in the respective versions. All you need to do is add the Angular Animate module there, in the same version of the AngularJS preferably, then open your command prompt or your terminal, navigate to the application folder, and do an npm install. This will include your module to the Bower components folder of your app. So now, to have it on your app, you need to add the script tag on the index.html. Okay, now the last thing you need to do is to include the ng-animate module as a dependence module of your application. Go back to your app.js file and add it. The ng-animate module will help you to deal with your CSS and JavaScript transitions by attaching special classes to some elements during its transition events. The ng-repeat element, for example, will gain special classes when new elements are in the process of being added and being removed from the array. Let's see it in action. First, let's add a new class to the ng-repeat elements, just so we can attach some CSS to it. We'll set all the CSS transitions on the elements to take 1 second. Now, if we go back to the browser, we'll notice that some special classes are added to the element for a second before the element disappears. Now let's go back to the CSS and make some use of this. Change the duration to 0.3 and then add this to your CSS. The ngLeave and ngLeaveActive are two classes added to the element on the transition begin and end. By changing the height from 0 to 50 pixels, we got a delete-chain animation. Now going back, by adding the opposite to the classes that are triggered on the enter event, we get an animation from element addition and from element removal. The same animation interval will be used for your color transition, so our highlighting is now also smoother. And that's it. That was our to-do list application. The code for it is available among the files of this course. In the next section, we're going to start a new application that will teach us about some new concepts of AngularJS, like partial views, routing, and much more. See you there. Hey guys, welcome again. In the last section, we developed our first AngularJS application, but it was a very simple one, with a single view and a very simple model. In this section, we're going to build a second application. This time, however, we're going deeper into the framework and we're going to learn how to deal with complex models, HTTP requests, needing multiple views and controllers, routes, and services. I'll call this new application we're about to start Movie Database, and will be a movie catalog with advanced filtering options, a movie details page, and much more. But instead of just talking about it, let's go ahead and build it. We're gonna kick off this application exactly as we kick off the last one, by using the Angular seed boilerplate. Let's copy the clone link, then let's go to our command prompt or to our terminal, and let's create a new folder for our project. Then let's use git clone to copy the Angular seed project again. After git finishes cloning, let's go to our text editor and open our project folder. Then let's clear up the application example again. Let's remove everything from index.html. Let's remove indexasync.html entirely. Then let's remove the contents of app.js and app.css. Let's also remove the view1 and view2 directories. Then let's open up the components directory and clear it out as well. Now let's head to index.html and start laying it down. Let's start with HTML, tag, language English, and then let's name our application MovieDB using the ng app directive. After that, let's add ng controller catalog controller, which will be the name of our controller. Then let's add a head, a body, separate those. Let's add the meta character set tag, and then a title to our page. Let's call it AngularJS movie database, and a link to our application CSS. Near the end of the file, let's add our JavaScript imports. First, let's import AngularJS, then app.js, and then a file named catalog/catalog.js. This will be the file to contain our first controller. Then let's go on and create it. Let's create the catalog directory and the catalog.js file. The reason we're creating this file is that, unlike the previous exercise where we had a single controller in a single file, this time we're going to have multiple controllers located in multiple files. It is a good practice to have a directory to contain each component of your app. In this case, the catalog screen gets its own directory that for now will contain only the controller and later the template and the test files for the catalog screen. Then let's go to app.js and actually register our application. We're gonna use Angular module, we're gonna call our application MovieDB, and let's include a new module called moviedb.catalog. Now let's go to catalog.js and create the catalog module. Let's use the Angular module again, call it moviedb.catalog, pass no dependencies, and let's register a controller in it. Let's call it catalog controller, because that's the controller we want to be in charge of our catalog page. Let's add the scope service as dependency, and now we're ready to start our controller. Now that we have our blank application wired up, we want to add a few more things. First, let's include the Bootstrap CSS framework, like we did last time, so we can deal more easily with CSS. This time, instead of downloading the CSS manually, let's do it a different way. Let's go into our bower.json and let's add Bootstrap as a dependency for our application. Let's leave the version blank so it gets the latest version. Now you're ready to go to your terminal or your command prompt and do an npm install. Again, this can take a minute, but once it's done, you can go back to your index.html and add the tag to import Bootstrap. Let's add a link, and the reference is bower components, bootstrap, dist, css, bootstrap.css. And that's it. Bootstrap's now part of our application. And now we are all set for a clean start. Before jumping in the application logic, however, there is one more thing we need to add to our project. If you want to build the movie gallery application, then we're going to need some movies to work with. Among the files provided for this course, there's a folder called exercise 2 assets. And inside that folder, we have two subfolders. The EMG folder that contains images of movie posters and the JSON folder. The JSON folder contains two files, movies.json and genres.json. Those files contain the models we're going to use into our application and will basically work as a local database for our app. We're going to analyze the anatomy of these files in the next video, but for now, we only need to include them into our project folder. So let's grab both folders and copy paste them directly to our app folder. And now we're ready to move on. In the next video, we're going to learn how to deal with those files and how to request data in AngularJS using the HTTP service. I see you guys there. Hey guys, we have set up the groundwork. Now we are ready to start moving on with our movie application. First, Let's take a look at our movies.json file and check out what we find there to work with. If you're not familiar with JSON, this file may look a little bit confusing, but it's actually pretty simple. Remember how we built a task array in the last section containing the attributes of each one of the tasks? This is no different. The whole file describes an array of movies. Every movie is a hash containing several attributes, which represent the properties of the model. Let's pick up the first movie in the array and take a look at its attributes. We have a title, an ID, the original title for foreign movies, an overview attribute containing the movie synopsis, a poster path attribute containing the name of the file that corresponds to the poster of that movie, and many others, including some nested attributes like genres. If you pay attention, you'll notice that the genres attribute is an array in itself, and it also contains multiple objects in it. In other words, each movie can be associated with multiple genres, and this array contains the list of those genres. I know, it's a fairly complicated model, and maybe it contains more information than we are actually going to need. But this is intentional, and it will be a very realistic example of how data is handled by real API services and how we'll put those objects to use in AngularJS. So let's get to it. First, we need to know how to import this data into our application. For that, we're going to use a new service called the $HTTP service. The HTTP service provides a layer on top of JavaScript's XML HTTP request and allows you to make asynchronous HTTP requests and retrieve data from a server. In other words, it makes AJAX calls. So let's include the HTTP service to our controller and use the get method to request the contents of json/movies.json. Then, if the get method succeeds, we're going to execute a function. That function will get the retrieved array as a parameter called data. So let's get that data and put it into our scope. Let's create a new variable on the scope that will contain our movie list. Let's call it scope.movielist. And let's assign the data to it. Now the movie list is available in our scope. Let's go back to our index.html and print the object as JSON, just to make sure that what we've done until that point is working. For that, we'll use an expression, print the value of movie list and then add pipeline JSON, so AngularJS knows that it should apply the JSON filter on the data before printing it. The JSON filter basically turns the JSON object into a string, so it can be printed as text on the template. Now, go back to your browser and check it out. The movie list is successfully coming from the movies.json file and being printed on the page, meaning our HTTP request was successful. There is only one little problem to be noticed here. If you're running your Angular application in a web server, being it a node server that we learned to set up using the npm start command or any other, this information will show up for you. But if you're opening your index.html file directly on Google Chrome, it's possible that you get an error when you try to load the JSON. This happens because of Chrome's implementation of something called Same Origin Policy. The Same Origin Policy is a browser restriction implemented in all modern browsers for security reasons, and it forbids your application to directly access files cross-domain. In Google Chrome, however, two files loaded into the browser directly from the local disk are considered cross-domain, and you get an error. You can avoid this error by either using a local server or using Firefox or Safari instead of Chrome. Now let's go back to our index.html and let's make this into an actual gallery. First, let's add a few bootstrap elements to organize your page. Let's create a div container and inside of that another row div. This will wrap our application into a responsive container. Let's then create a well div. Then let's add call sm10 and call xs12. Those classes are basically telling Bootstrap that our container must occupy 10 out of 12 columns of the grid system in small screens and beyond. But in very small screens like cell phones, it will take the entire width of the page, or all the 12 columns in this case. Then let's add another row, and finally, the div that will contain our movies. Let's name it movie container. And let's add the classes call sm2 and call xx6 And that will tell Bootstrap that we want 6 movies per row on computer screens, but only 2 on cell phones. Finally, let's add the ng repeat directive, movie in movie list, so we print our movies one by one. Now let's add the actual poster. We want the movies to be clickable, and clicking a movie should take you to the details page. So let's add a link. We can leave the href blank for now and add the class movie thumb. Inside that link, let's add the movie title as a heading and the image, that is the poster, as a thumbnail, img responsive. Then we add the src of the image, which will be img/posters plus the movie poster path. Pay attention to the fact that inside of our img posters folder, every poster has a random name, and this name is instantiated in the movie.posterPath property. Now you can go back to the browser and check that it's working. Okay, it doesn't look very good yet, but let's ignore this for a moment and take a look at the console. If you look at the JavaScript console, you're gonna notice an error indicating that the application failed to load the resource, specifically an image called img posters and a lot of this stuff. This error is caused because when Angular first loads the page, it loads the templates first, and then it processes the directives. When the templates are loaded, the browser thinks this expression is a real link, so it tries to load the image, and only afterwards AngularJS replaces the expression with the real link. To avoid this from happening, let's get back to index.html, and instead of using the src attribute, let's use the ng-src directive. The ng-src directive works exactly like the src attribute, but will not cause that error. Go back to the browser, reload the page, and the error is now gone. Okay, now we actually have a movie gallery, but it looks kinda ugly. Plus, we have too many elements being showed on the same page. On the next video, we're going to add some more CSS and also add some pagination to our gallery. See you there. Hey guys, we managed to retrieve the data from the JSON and show it as a movie gallery. Our only problem is that our application still looks kinda terrible. So let's go back to the index.html and add a few extra elements. First, let's add a title to the movie gallery by creating a div here, telling Bootstrap that it's a full width div, then adding div class page header, and let's title it most watched movies this week, or just most watched this week. Let's add an extra class to use in our CSS. Let's name it section title. Now let's go to our app.css and add some styles. Remember the Google font we used last time? It was cool, right? So let's use it again. Let's add an import and Google API, CSS, and okay. And let's get a section title and give it a few attributes. Let's use the font family Lobster. Let's change the font weight, line weight, font size, and remove the margin. Then we're gonna limit the height of the movie container. And finally, let's add some attributes to the movie thumb itself. Let's align the text in the center and change the color to black. And then in the H5, let's put the font weight as bold and add some margin top. Finally, when you hover it, we don't want any text decoration and we want the color to change to gray. That must do it for now. Let's go back to our browser and check it out. There's still some margin under the thumbnail we don't want, so let's go back to the CSS, add thumbnail, margin button 10, and then let's limit the height of the thumbnail to 200 pixels. Going back to the page, and it's good. It still looks a little raw though. Let's try adding a navbar. Go back to your index.html, and on top of the container, let's add a new navigation element, and let's class it navbar navbar fixed top to tell Bootstrap that the navbar is gonna be fixed on the top of the page, and navbar inverse to make it black. Inside of the nav element, we're gonna add a div container and a link that we're gonna call navbar brand, and we're not gonna link it anywhere yet. And inside of that, let's add the name of our application, movie db, and let's also add a span glyph icon just to make it prettier. Now let's go back to app.css, add some margin on the top of the body so we have some space for the navigation, and let's make the navbar brand use the same font as the section title. Now go back to your browser, reload your page, and it looks slightly better. We can work with that. Now, for the next step, pay attention to the fact that our gallery is showing every single movie on the list. We don't want that to happen, so what about adding some pagination to it? Bootstrap happens to have a pagination component that can help us out with that. Remember that I previously mentioned the project called Angular Bootstrap or UI Bootstrap? This project is basically an Angular module that implements all the Bootstrap JS components using pure AngularJS instead of jQuery and Bootstrap's JavaScript. To include this module to our app, let's go back to our bower.json file. Let's add the Angular Bootstrap package without specifying any version, and then let's go back to our command prompt or terminal and install it using npm install. This will install the Angular Bootstrap module into the Bower components folder. Now go back to our index.html and let's add the Angular Bootstrap script here. It's important, however, that you add the Angular Bootstrap /UI-bootstrap-tpls.js file instead of the one just named UI-bootstrap.js. The TPLS version contains the templates for the Bootstrap components, and it will make our life easier. This will make the page load the module script, but it won't add the module to our application yet. For that, we have to go into our controller, or alternatively, to our catalog.js, and add the UI Bootstrap module as a dependency, so AngularJS knows it has to inject it. Now we got the module going on our controller. Time to create a couple variables we're going to use. First, let's create a scope.currentPage variable and a scope.pageSize variable. The current page will keep track of which page we are on the pagination. The page size will define how many movies per page we want to show. Let's set it to 12. Then, back to our index.html, let's add the pagination directive near the bottom. Let's add the pagination class, and now we only have to pass a few parameters to the directive in order to make it work. First, the total items indicate how many movies there are in total, so let's pass the length of the movie list array. Second, the ngModel attribute will be the variable the pagination will use to keep track of the current page. Let's pass the current page attribute to it. Finally, the items per page attribute is pretty self-explanatory. Let's assign the page size variable. Now, if we go back to the browser, you'll notice that the pagination was added to the very bottom of the page. The buttons work, and the Angular Bootstrap module makes sure the current page is up to date with the value indicated in the pagination. Despite of that, the pagination does not affect the movie gallery yet. In order to do that, we need to somehow filter the gallery using the pagination variables to only show the movies from the page we're currently at. AngularJS does not have a built-in filter for that. So let's take this chance and learn how to write a quick custom filter. Let's create a new file to contain our filter. Let's create a new directory called paginate inside of the components folder. And in this directory, let's create a new file called paginate-filter.js. And inside this file, we're gonna create a new module called moviedb paginate-filter. Inside this module, we're going to register a filter called paginate. The paginate filter will return a function that gets 3 parameters: the movie array, the current page, and the page size. Then, we'll return the same array, but we'll slice out everything that comes before and after the current page using the slice method. It's important to add some error handling here, because the movie array is loaded asynchronously, so you can get an error if you try to filter the array before it's actually created. Finally, let's add the new module to our application by going back to index.html and loading the paginate filter file. Don't forget that we also need to inject the module into our application on our app.js. Back to the index, the only thing we need to do now is use the new filter. Let's go to the ng-repeat tag, add a pipeline, and then pass the filter name and its two parameters. Finally, go back to our browser and test it out. It works. Now I'm happy with the movie gallery. In the next video, we're going to introduce multiple views to our application alongside all of the concepts and components we're going to need to do so. See you there. Hey guys! In the last video, we set up a movie gallery. But what's a gallery good for if you can't check out the movie details? It's time to add a second screen to our application, the movie details page. In order to do that, we'll have to introduce a new concept that I didn't explain in detail yet: Angular routes. A web application is composed of several different pages. In a regular application, your location inside the app is defined by the URL you request. For example, if you go to facebook.com, it will take you to a profile page. But if you go to facebook.com/messages, it will take you to your inbox. In a single page web application, however, the entire app actually runs on the same page. This means AngularJS needs a different way to deal with the routes and define your location in the app, so it can load the right view, the right template, and behave just like a regular application for the final user. That's when the Angular route model comes in. The Angular route model is included in your bower.json file by default. All you need to do now to load the module is to include the file in your index.html. Now to inject the module, go back to your app.js and include ng-route in your dependency array. Now that we have included the module, it's time to configure our first route. Let's use the config method to add a configuration function, and let's pass as a parameter to that function the $route provider object. The route provider is what you use to configure the routes of your application. So let's use it to define our first location. Add route provider.when/ and then a hash containing template URL, and let's add catalog/catalog.html and a controller that will be catalog controller. Let's also add a second one that will be otherwise redirect to /. What I'm doing here is very simple. I'm telling the application that whenever the user goes for the root of the application or the / location, AngularJS is supposed to load the template that is located in catalog/catalog.html, and it's supposed to load a controller named catalog controller. The second line tells Angular that any other route that the user inputs that is not defined in this configuration should redirect to the root. The only problem is we don't have a file named catalog/catalog.html, so let's create it, and then let's go into our index.html and let's transfer over the section that corresponds to the template of the gallery to that file. Now back to index.html, let's add a directive called ngView. The ngView directive tells AngularJS where the partial is supposed to be loaded into the page. So it will replace the directive with the code contained in your partial. Also, when we're using the route provider, the controller that will be in charge of that view is defined in the route itself. So we can go to the top of the file and remove this controller tag, and then go back to the browser and test it. It works just like before. But now we're loading a partial instead of having the whole template in a single file. Also now, if you go to the URL and you input any route here, it will redirect you back to the root. Now, let's go ahead and create a new page for our application. Go back to our app.js and add a new route. Let's do it when movie/id template URL movie/movies.html and controller movie controller. The difference here is that we're getting an ID parameter from the route. And of course, we didn't create this template or this controller yet, so let's do that. First, let's create our movies directory, and inside of the movies directory, we're gonna create a file named movie.html that will be our template, and another one called movie.js that will contain our controller. Then let's add the controller in the index.html, and now we're ready to code the controller. Let's create a new module here called moviedb.movie, and then let's go back to our app.js and include that module into our application. Back to the movie.js, and then let's add a new controller to it called movie controller. We're going to use a few services in this controller, so let's add the ones we already know. The scope service, the filter, the HTTP, and a new one we didn't use yet, the route params. We can use the route params to retrieve the parameters we defined in the route, like this. Scope movie ID gets route params.id. Then we can use that ID to select only the movie we want from the list and show its details. So let's copy over the HTTP request that recovers the list from the catalog controller, and then let's make a few adjustments. Let's use the filter service again to filter our data and get only the record that has ID matching the scope movie ID. And we're gonna use the parseInt variable here, otherwise it's gonna go as a string and the comparison will fail. Let's also change it from movie list to just movie. Now let's create the template we need to show this. Let's go to our movie.html and let's just add an expression printing the movie title. Then let's go to our catalog.html and let's link the movies in the galleries to the details page. Just add an href hash movie ID. Now you can go to the browser, reload the page, click in one of the movies, and there it is, the title. Now let's write the actual template to make this look nice. In the next video, we're gonna turn this blank template into something useful. See you there. Hey guys, time to write our new template for the movie details page. Let's go for the movie.html partial. Let's remove the stuff we have. Let's add a new container classed well movie details and call XS12 for full width. Then let's add some of the attributes we want. First, let's add the poster. So we're gonna add an image of poster, image thumbnail, image responsive, so it's responsive. And let's use the ng-src img posters movie poster path, just like the catalog. Then gonna add the movie title. Let's make it an h1. Let's class it movie title so we can add some CSS. And let's print the title and the release date of the movie. For the release date, we're gonna add a filter called date to format the date just for years. Let's then add a small list of the genres of the movie. Let's create a link and let's make it an ng repeat genre in movie genres. Let's add some classes so it looks like a button, and then genre name. Then let's add the overview, that is the description of the movie, by printing out movie overview, and a few extra details. Let's create a div called extra details, and let's add a few attributes here like runtime in minutes, the country where the movie was produced, which is in production countries. Let's get the first one, a name, the language of the movie, that it's movie, spoken languages, the first element in the name, and the release date. Let's use move release date and then pipeline date so it formats like a complete date. Now if you go to the browser and reload the details page, our details are here. They look kind of messy. Let's go to app.css and add some styles. First, let's get the movie details poster and align it on the left, add some margin on the right, Then let's move to the movie title. Let's use the Lobster font family again. Let's set the font size to 35 and remove the margin on the top. For the genres, let's add BTN info and let's add some margin on the right. And for the overview text, let's readjust the font size and add some margin on top, bottom, and on the right. And finally, we can go back to the browser and it looks way better. Now you can see a few of the other movies and they're all looking nice. You know what would help here? A return to catalog button. Let's go back to our movie.html. Let's add right under the image a link, class return link, that will point to hash. And let's add a button. The class is going to be return button and button default, so it looks white. And return to catalog. Let's also add a little arrow here using the spam glyphcom arrow left. Now let's just add one little extra detail to app.css. Let's get the return link and align it on the right. And that should do it. Let's go back to the browser again, reload, and our nice button is here. And that's it, a nice details page. In the next video, we're going to learn a bit about creating custom services and using the same template for multiple controllers. See you there. Hey guys, welcome again. At this point, we have an almost functional application in our hands, but there are some changes we can do to make it even better. First, let's take a look at our catalog controller. We're using the HTTP service here to retrieve the JSON file that contains the movie list. But truth being told, we shouldn't be doing any HTTP requests inside of the controller. The controller is meant to manipulate our data and prepare it to be used in the template, but it's not a good practice to handle the HTTP API calls directly into the controller. A better way to organize that would be to use a service to contain this data retrieval logic and abstract it away from the controller. In this case, where we're using a single and very simple HTTP call to get our data, this may look superfluous, but in a large-scale application with complex API services and multiple models, putting all this logic inside of the controller will make it a mess. Up until this point, we have been using several different services. The scope service, the HTTP and the filter services, the route parameters, and so on. Now, it's time to learn how to write and use our own services. Let's start by creating a service to abstract the HTTP calls away from our controllers. First, let's open up the components folder again and create a new directory called movie. Inside of the movie directory, let's create a file named movie-service.js to contain our service. Inside of that file, let's create a new module called moviedb.movie-service. And let's register a factory in it. Let's call it Movie API Service. By this point, you should be familiar with creating and managing modules already. So let's go back to our index, import our module, and then go to our app.js and inject our module. Then we can go back to services.js and start coding it. We're first going to include the HTTP service as a dependency of our custom service. Then, let's create a new variable called movie API, and let's add a new method to it called getMovies. GetMovies will simply return the http.get JSONmovies.json. And then the service is going to return the movie API. Now we can go back to our catalog controller. We can remove the HTTP service from the dependencies and replace it with the movie API service. Then, instead of using HTTP request, let's use the movie API service.getMovies method. And it's done. The API logic was now moved to the service. Now you can go to our movie.js and do the exact same thing. Place it here and here. And then you can go back to your browser, test it, and it's still working. Now there is one last piece of functionality I want to add to this app. Let's make a list by genre. Remember the genres.json file we put in the JSON folder in the beginning? That file contains a list of all the movie genres that are used in the movie list. Each genre has an ID, a name, and a total that represents the total number of movies in the movie list that belongs to the genre. To retrieve this data, let's go back into our movieservice.js and let's add a new method to movie API called getGenres. And it works just like the getMovies, but instead of the movies, it will get the genres file. Now go to the catalog controller on catalog.js and let's add a new variable here that will get the genre list for us. Let's use the movie API service again and the getGenres method we just created. And the rest will be just like the getMovies one, except we're gonna call the variable genreList. Now let's go to the catalog.html file and let's add something new. Go to the bottom, let's add a new div, call sm2, so it only occupies 2 columns of the 12. And inside of that, let's add a title, class it section title, genre title, by genre. And to contain the genre list, let's create a bootstrap element called a list group. This list group will contain a first initial link that will have href pointing to hash, and it will be a list group item, and that says all. And it has a badge containing movielist.length. You're gonna understand what this is about in a minute. After that, the important part. Let's create another link. Let's class it list group item again, and this will be our ng repeat element. And we're gonna add one of these for each genre in the genre list. And each item will contain the genre name and a badge containing the total number of movies in that genre. Let's make just one little CSS adjustment in our app.css. Let's add a genre title class and align it on the right and add some margin to the bottom. Now you can go to your browser, go back to your catalog, reload it, and boom, genre list. But this genre list doesn't do anything yet, so let's work on that. So now let's go back into our app and let's create a new controller. Let's first add a new directory called genres that will contain the files of our genres screen, and inside of it let's create a new file called genre.js. And let's copy paste the content of catalog.js to it and make a few adjustments. The reason I copy pasted the controller is because we're gonna use the same template again. So many of those elements will just stay here. Let's change the module name to genre. Let's change the controller name to genre controller. And let's add a few services to the dependencies list. Let's add the route params and the filter services. Now let's go back to our app.js and let's add a new route. Let's say that when the route is equals to genre/genre name, that is a parameter, then the template URL will be catalog/catalog.html, the same one you have used before, and the controller will be the genre controller. Then let's import the genre module into the app. Now the controller will get the genre name parameter from the route. Let's go back to the controller and make some more changes. Let's create a scope variable called genre name. Let's use the route params again to retrieve the parameter value from the route. Now, when the user goes to genres/genre name, the controller knows which genre he wants to visualize. So to get the movies that belong to that genre, you only need to do a little extra filtering in the movie list variable. Instead of just returning the data, let's use the filter service to filter out only the movies we want to show. Add filter of the filter kind, pass the data array, and let's define a function that will be our filtering method. Let's pass the movie as a parameter, and what that will do is that the filter service will repeat that method for each item in the list, and either remove it or not from the list depending if the result of that function is true or false. And as the return value here, let's use another filter. Let's filter the list of genres of a given movie and let's see if we can find any genre on the list that matches the one provided on the route. If the array returns any element, the function will return true and the movie will be shown on the page. Now that our controller is done, don't forget that we have to go back to index.html and import it. Now, we only need to link the genre buttons to our new controller. Go back to catalog.html, go to the bottom, and on the href add #genre/genre name. And it's basically done. Go back to your browser, reload the page, click a genre, and you're gonna go to a page that only contains the movies of that said genre. But it's not very clear right now which genre are we looking at, unless you look at the route. So let's add some elements to the page. Let's go back to our genre controller and let's add a new scope variable called page title. And let's assign genre name plus movies to it. Now go back to catalog.html and near the top, where we used to have most watched this week, let's just make it page title. But don't forget, this is the same view we use in the catalog controller. So let's go to the catalog controller and let's also add a page title, and there we're gonna assign most watched this week. Now when you go back to the browser, it's almost good. But it could be better if you could highlight in the list the genre that is currently active. So let's go back to catalog.html near the bottom and let's add a new ng class, and let's add the class active in case the genre name matches the genre name passed as a parameter to the route. Now go back to the browser and check it out. It works, and so does the pagination. Now we can consider the exercise completed. I hope it helped you to better understand the mechanics of AngularJS for routing, dealing with data, and multiple partial views. In the next section, we're going to go back to the beginning and review the AngularJS most important directives. We will revisit the ones we already used alongside the ones we haven't seen yet. Then, we're going to learn how to create our own custom directives. See you there. Hey guys! One of the main principles of the AngularJS framework is to extend the HTML vocabulary for your application, turning your markup into a more concise, readable, and meaningful templating tool. This is achieved by the use of directives. Directives are a fundamental part and one of the most important aspects of AngularJS. In this section, we're going to take a deeper look at Angular directives. We're going to review the important directives we have already seen, and then we will dive in and learn about the process of writing custom directives. So let's get to it. First of all, AngularJS comes bundled with a wide variety of directives that will serve many general purposes on your application. Let's take a look at some of the most important directives available in the framework by default. Let's open up some code from previous exercises again and see what we find. First, the ng-app directive is responsible for auto-bootstrapping your AngularJS application. It designates the root element of the application and is typically placed near the root element of the page, like the body or the HTML tags. It basically defines where your application starts and ends within the page. Moving on, we have the ng model directive. This one binds an input, select, text area, or custom form control to a property on the scope, providing two-way data binding between the value of the property and the value you see on screen. The ng model gets an expression as a parameter and will try to bind to the property given by evaluating the expression against the current scope. If the property doesn't already exist on the scope, it will be created implicitly and added to the. Then we have the ng repeat directive that replicates a template once per item from a collection. Each template instance gets its own scope, where the given loop variable is set to the current collection item and $index is set to the item index or key. The $index is not the only special property available in the ng repeat scope, however. Here's a table of the special properties you can use inside of your ng repeat loop. Another thing to note about the ng repeat directive is that you do not necessarily need a single HTML element to contain your whole template. If you have a long template or want to define explicitly a starting and an ending point to the repeat template, you can use the ng-repeat-start and ng-repeat-end directives, like in the following example. In this example, the entire markup will be considered as the template, including the header and the footer tags. Then, we have the ng-controller directive. It attaches a controller class to the view. This is a key aspect of how the model view controller pattern is handled in AngularJS. The ng-controller takes a single parameter, which is the name of the controller you want to be in charge of your view. As we saw in the application we developed in the last section, the use of Angular routes allows you to bind your views to your controllers without necessarily having to use the ng-controller directive. Still, it's a very useful thing to know. Speaking of routes, the ng-view directive complements the route service by including the template of the current route in the main layout file. Every time the current route changes, the included view changes with it according to the configuration of the route service. It requires the ng-route module to be installed, but it's still one of the most important ones. It does not take any parameter. Moving on with the directives, it's time to take a look at the event handling directives available in AngularJS. But first, let's stop for a second and talk about the Angular way of doing event handling. If you ever used jQuery and try to bind a method to the click event of a DOM element, you probably use something like this. In AngularJS, however, you would simply have something like this. This is a major shift in the way you use to bind methods to event handlers using JavaScript, and it's a good example to illustrate how Angular templates are powerful. In the old jQuery way, in order to understand the event handlers, you need to read the HTML template and the JavaScript that associates the action with the DOM elements. In AngularJS, it's way simpler, since the HTML element, the event handler, and the action are all declared in a single place. There are as many directives as possible DOM events. You can use ng-click for the click event, ng-submit for the form submission event, ng-mouseover for the mouseover event, and the list goes on and on and on. Now, let's move on for the next directive, the form directive. But wait a minute, just form, no ng? Is that even a directive? Doesn't HTML already have a form element? Well, since the role of forms in client-side Angular applications is different than in your classical apps, it is desirable for the browser not to translate the form submission into a full page reload that sends the data to the server. That's why AngularJS slightly changes the behavior that you would usually expect from the HTML form element. So, when you use a form in your AngularJS app, you're actually using the Angular form directive, not just the HTML form. By default, the Angular form prevents the form submission to the server unless the form element has an action attribute specified. You usually use that action to hook up the controller action that handles your form. You can use one of the following two ways to specify what JavaScript method should be called when a form is submitted. You can use the ng-submit directive on the form element like this, or you can use the ng-click directive on the first button or input field of type submit. Now, let's take a very quick look at some other Angular simpler directives that can be extremely useful. The ng-hide and the ng-show directives will hide or show your element via CSS, depending if the expression passed returns true or false. The ng-switch directive is used to conditionally swap DOM elements on your template based on a scope expression. If your template structure depends somehow on a conditional, just use the ng-switch as the following example. The ng-class directive will add arbitrary CSS classes to your element if the expression returns true. The ng-style directive allows you to bind arbitrary inline style to elements, like the following. The ng-disable directive, in a similar fashion, will set the element as disabled or not depending on the expression returning false or true. The ng-pluralize directive, we've seen this one in action before, will help you to display messages that may have a plural form depending on a numerical value. like a view counter in the following example. Finally, AngularJS sometimes may cause problems during page load times trying to load source URL and hrefs before the expressions are resolved. To avoid that, we generally use ng-src and ng-href instead of their pure HTML counterparts. This will prevent resource load errors and wrong links during your page load. And those were just a few of the most used directives available by default in Angular. It's not my intention to cover every single directive here, but it's good to at least have a place to start. In the next video, we're going to find out how to write our own custom directives and implement any behavior or application needs that's not available by default. See you there! Directives are the most important components of any AngularJS application. As we saw previously, AngularJS comes bundled with a wide variety of directives that will serve many general purposes on your application. There will be times, however, when you will need to write your own custom directives. Directives can be as complex as they need to be. They can have their own controllers, their own scope, templates, and dependencies. They can communicate with each other and share properties. Because of that, writing custom directives in Angular can be tricky, depending on how complex is the behavior you want to implement. But the logic behind writing directives is not very different from the logic behind the templates and views of your project. It's just a matter of encapsulating the pieces of your application as reusable components. Let's see how a simple directive written in Angular looks like. The directive method registers a new directive and works the same way as any other module, but it returns a simple object, the directive definition, that contains several properties to configure your directive. The following code is an example of a simple Hello World directive. All the Hello World directive will do is to show a div containing the text Hello World. There are several things to notice in the simple example, however. The first is that, while declaring the AngularJS directive, the name convention followed is camel case, but when you actually use the directive in your HTML, you will use the dash notation instead. So Hello World will turn into Hello-World into our HTML. Then we have three directive properties being declared. The first is the restrict property. The restrict property will define the way your directive can be declared in your template. An AngularJS directive comes in four flavors in terms of appearance. It can be a new HTML element, an attribute on an element, it can be a class, and it can be a comment. To define which form will be valid for your directive, all you need to do is assign the restrict property with the respective letter. It's also permitted to have more than one possible notation, so the restrict property will take more than one letter if necessary. Then we have the template property that defines an HTML template to your directive. If your template is big, however, you can use the template URL property instead to define a path to the file that contains the directive template. Last, we have the replace property that defines if the template must replace the directive tag entirely or be appended as a child of the directive root element. Up to this point, it sounds very simple, but it quickly gets complicated when you take a look at all the possible properties that a complex directive may need to contain. So let's take a look at one by one and try to understand when we're going to use each. We've already seen the first four, let's take a look at the others. First, we have the transclude property. When you use a template in your directive, AngularJS will either replace the content of your element with your template, or the element itself, ignore anything that you put inside it. There may be a time, however, when you want your directive to consume the existing content of the element into a template. That's what the transclude option is good for. If you set transclude to true, the content of the element will be stored and you'll be able to invoke it in your directive template using the ng transclude directive. Then we got the priority property. The priority is only relevant when you have multiple directives on one element. The priority defines in what order those directives will be processed by AngularJS compiler. Then we have the scope property. By default, AngularJS directives will not create a scope of their own and will share the scope of the parent controller. You can use the scope property, however, to set up a private scope for the directive. Then we have the compile and link properties. This is probably the most confusing part. To understand what's going on, we'll have to take a look at how AngularJS processes a template. When the AngularJS process starts booting up, the first process that happens is that the HTML is parsed by the browser as a DOM tree. This tree is then parsed using AngularJS's compile method. Compile runs through the DOM tree and looks for directive declarations. Once all the directives are found, then each directive's compile function is run and is expected to return a link function. Finally, the linking function is invoked with the containing scope that attaches all of the associated directives to that scope. This is where we will do most of the work when building directives, as this is where we can register listeners, set up watchers, and add functionality. The result of this process is why the live data binding exists between the scope and the DOM tree. In other words, we'll use the compile function to both manipulate the DOM before it's rendered and return a link function. We'll use the link function to register all listeners on a specific DOM element that was cloned from the template and set up our bindings to the page. You're not actually supposed to declare both compile and link properties on the same directive. You either declare a compile function that will return a link function, or you just declare the link function. On top of that, if you want your directive API to be exposed to the other directives, best practice recommend that you declare it as a controller instead of using a link function. The basic difference between link and controller functions is that controller can expose an API, and link functions can interact with the controllers using require. That takes us to the required property. You can use the required property to inject the controllers of other directives into your compile or link functions. By default, Angular will look for the controller only on the directives on the same element. However, we can prefix the controller name with a circumflex to tell Angular to look for the required controller on the parent element of the directive element. And we can prefix with a question mark to tell Angular not to raise any errors in case the controller is not found. And this is the anatomy of an AngularJS directive. It may look a little bit overwhelming at the first glance, but as you get the hang of the framework, the process of writing directives will naturally become fluid. In the next video, we're going to take a look at AngularJS filters, how to use them to deal with your data, and how to write your own custom filters. See you guys there. Hey guys! In AngularJS, filters are very important when dealing and displaying data. A filter is a function that formats the value of an expression in order to display it to the user. This includes filtering elements of arrays in order to refine lists and so on. They can be used in views, controllers, or services, and it's easy to define your own filter. If you want to use a filter directly on your template, you can apply it to expressions using the following syntax. For example, the expression 10 pipeline currency formats the number 10 using the currency filter. The resulting value is $10.00. There are filters more complex than this one, however, and complex filters may have arguments. The syntax for this case is expression, pipeline, the name of your filter, and your argument separated by column. Now, if you want to use a filter on your controller or on a custom service, you can do that by injecting the $filter service on your module and using the following syntax. $filter, the name of your filter, the input expression, and your parameters. This method will return the filtered object. AngularJS has a series of built-in filters to help you out displaying your data. You can also create your own filter, but first let's take a look at the filters available by default. Starting by the simpler ones, Angular has filters to deal with currency, dates, formatting numbers, and letter case. Those are respectively the currency filter that by default will set your number to dollars, but can use different symbols if you pass the symbol as a parameter. The date filter that will format your date in any way we specify in the format parameter. The number filter that will format your numbers and fractions, letting you choose the number of decimals that have to be shown. And the lowercase and the uppercase filters that do exactly what they sound like they do. Then we have the JSON filter. The JSON filter will get any model you want and print it in the JSON format. As simple as that. Finally, we have some more complex filters especially fit to deal with arrays of data. The limit_to filter creates a new array or string containing only a specified number of elements. The elements are taken from either the beginning or the end of the source array or string, as specified by the value and sign, positive or negative, of the limit parameter. The other by filter orders a specified array using the provided expression predicate. It is ordered alphabetically for strings and numerically for numbers. An example of how to use it would be, let's say you have a friend list defined on your scope, and then you can do friends pipeline order by name, and that will return Adam, John, and Mary in alphabetical order. There's a filter just called filter. This one will expect an expression and possibly a comparison function to evaluate which elements should be filtered out of the array. It sounds complicated at first, but it's not. The expression parameter is the predicate to be used for select items from the array. The expression can be a string that will be used for substring match against the contents of the array. The expression can also be an object that will be used to filter specific properties of objects contained by the array. And lastly, it can be a function that you can use to write arbitrary array filters. The function is called for each element of the array. The final result is an array of those elements that the provided function returned true for. Finally, if you're not happy with the default case insensitive substring match as the match method, you can pass a different comparison function as the comparator parameter. If you just pass true, Angular will assume the following method as a comparison method, or you can just write your own and implement any array filtering logic you like. And those were the filters available by default in AngularJS. Not many for sure, but if you need anything that's not covered by those, it's extremely easy to write your own custom filters. We actually created a custom filter to take care of our pagination in the last exercise. Let's go back there and check step by step what a custom filter looks like. Like any other module in AngularJS, your custom filter needs to be registered as part of your application. Let's take advantage of the fact that we already have a module containing a filter in our app. And let's register a new filter in that same module. Let's say you want to create a new filter to revert the order of the words in a string. First, you have to name your new filter. Let's call it revert words. Now, the important part is that your filter is supposed to return the function that will filter the input expression and return the filtered output. Now, since the model in which we register the filter is already in our application, we only need to go to our view and use it. Let's say we want to revert the words of the movie title on the movie details page. Go to the movie details partial view on the title line and add pipeline and our filter name. Go back to the details page and it's done. Don't forget that your filter can also be used on the controllers using the $filter service. And speaking of services, the next section is all about it. We're going to review the important services of AngularJS and learn a bit about custom services and factories. See you guys there! Services are another fundamental feature of AngularJS. Angular offers several useful services, some of which we've already seen in this course, like the $HTTP service. But for most applications, you will also want to be able to write your own custom services. But before we can talk about custom services, we need to stop for a moment and understand exactly what is a service. In Angular, a service is a function or an object, and is used to share data or behavior across controllers, directives, filters, and other services. Angular services are lazily instantiated, meaning that Angular only instantiates a service when an application component depends on it. And there are also singletons. meaning that each component that depends on a service gets a reference to the single instance generated by the service factory. This is different, for example, from a controller, of which many instances can be created. Like other core Angular identifiers, built-in services always start with the $, but the $sign is not mandatory for custom services. To use an Angular service, you add it as a dependency for the component, being it a controller, service, filter, or directive that depends on the service. Here is an example from section 3 exercise, where we're injecting the service called Movie API service. AngularJS dependency injection takes care of the rest for you. When it comes to declare custom services in AngularJS, there are a few different ways to do that. Those are called service recipes. There are 4 different service recipes you can use: the value recipe, constant, service, and factory. The first 2 are quite simple. Value and constant are services that are supposed to be used when all you want the service to do is to return a simple object. Here's an example of a service that returns the string hello world using the value recipe. You can use it in your controller or in other services by simply injecting the service and invoking its name. The constant recipe works basically the same way. The difference between a value and a constant service is that the first can only be injected in a service or a controller, while the second can also be injected into a module configuration function. Then we have 2 more service recipes. They're called service and factory. Yes, it's admittedly confusing to have a service type named service, but it's not that hard to understand. Let's take a look at this very simple example of a service called circle properties that is made to calculate the properties of a circle based on its radius. The service takes a function as parameter that contains 3 properties: pi, area, and circumference. Pi is a number, while area and circumference are the functions that will calculate the properties of the same name for a given radius. To use that service in your controller or in other service, all you need to do is to inject the circle service through dependency injection and then invoke the properties you want, like this. The factory recipe is not that different in terms of use. The difference between service and factory is simple. When you use the service recipe when declaring circle properties as an injectable argument, you will be provided with an instance of the function. In other words, you'll be provided with a reference to this function. When using a factory, on the other hand, you will not be provided with the function itself, but instead with the value that is returned by invoking the function reference passed to factory. In other words, if we were to write the same circle property service as a factory, we would do it like this. We would create a new object that contains the properties we want, and then we would return that object. And this is what we're going to get when we invoke the service in our controller. Services can also have their own dependencies. Let's get back to the factory example we created on section 3 and take a closer look into it. Here, we're invoking the $HTTP service and basically creating a layer around the API calls to abstract the HTTP calls away from the controller. This is a very common use for custom services in Angular. You ideally don't want to have URLs and explicit HTTP calls on your controllers, so it's very recommendable that you create custom services for this purpose. Speaking of HTTP, that's one of the most useful built-in services of AngularJS, but it's not the only one. In the next video, we're going to take a look at some of the most useful AngularJS built-in services and find out which ones you're supposed to use and when. I see you guys there. In the last video, we reviewed the process of writing custom services in AngularJS. But what about the services available by default in the framework? In this video, we're going to take a look at the useful services the framework already comes bundled with, starting with the ones we have already seen on this course. Let's start with the $HTTP service. By now, we're already familiar with this one, but we only used it for retrieving data. Now it's a good time to take a better look at it. The HTTP service is a function which takes a single argument, a configuration object that is used to generate an HTTP request and returns a promise with 2 HTTP specific methods, Success and error. A promise is an interface for interacting with an object that represents the result of an action that is performed asynchronously and may or may not be finished at any given point in time. In Angular, a promise is represented by the $Q service. Let's take a look at a template for an usual HTTP request. The success and error callbacks will be called asynchronously when the response is available or when the server returns a response with an error status. Also, if you're feeling lazy, shortcut methods are available. They look like this. The $HTTP service may be the default AngularJS service for dealing with HTTP requests, but if you choose to include the ng resource module in your app, you have access to a service that provides a higher level of abstraction when dealing with server communication, the $resource service. This service is a factory which creates a resource object that lets you interact with RESTful server-side data sources. The returned resource object has action methods which provide high-level behaviors without the need to interact with the low-level HTTP service. Here's the basic usage of the resource service. The resource takes several parameters. Let's take a look one by one. The URL is the destination of your call, with parameters prefixed by colon, like in the following example. The parent's default parameter is an array containing the default values for URL parameters. This can be overridden in action methods. If any of the parameter values is a function, it will be executed every time when a parent value needs to be obtained for a request, unless the parent was overridden. If the parameter value is prefixed with the @, then the value for the parameter will be extracted from the corresponding property of the data object, provided when calling an action method. The actions parameter is a hash with declaration of custom actions that should extend the default set of resource actions. By default, these are the actions available in the resource service and its respective methods. Finally, we got the options parameter. That is a hash and is supposed to contain custom settings, but only one available at the moment is the strip trailing slash boolean that defaults to true and strips out any trailing slashes from your URL. You may need to set it to false depending on your backend. Here is a simple example of how to use the $resource factory to, let's say, update the name of a given user model. The actions save, remove, and delete are available on it as methods with the $sign prefix. This allows you to easily perform create, read, update, and delete operations on the server side. Then we have the filter service. We have seen this one in action on the last section. It is used to format your model data and filter in arrays before showing it to the user. If you still have any doubt on the way it works, check out the segment about filters on section 4. Moving on to the next service, we have the $location service that parses the URL in the browser address bar based on the window location and makes the URL available on your application. Changes to the URL in the address bar are reflected into the location service, and changes into the location are reflected into the browser address bar. Then we have the $route service. The route service is used for deep linking URLs to controllers and views. It watches the location.url method and tries to map the path to an existing route definition. It's a service that usually works behind the curtains, but it contains a couple useful methods that you may have to use now and then. The reload method basically reloads the current view without the need of a change in the location. Of course, the page is never actually reloaded by the browser, so this method can be handy when you need a soft reload. The update params method is used to replace the URL parameters to those provided in the input hash. In addition to the route service, we have the route param service. That one simply returns a hash containing the URL parameters and its respective values. Now, let's talk about the $cache factory. It's a factory that constructs cache objects and give you access to them. The cache object is primarily used by the HTTP service and the script directive to cache templates and other data. You can also use it for your own purposes following this syntax. In the example, the myCache variable represents the cache object that you named cache ID. You can use the put method to add new keys and values to it, the get method to retrieve values, and the remove method to get rid of values. There are also a few methods to deal with sets of data. Moving on, there are a few extra services I would like to mention. When using AngularJS, you must completely avoid using global variables for testability reasons. The reasoning behind that is that the testing framework do not necessarily depend on an actual browser to run. These include even the JavaScript browser globals, like the window object and the window.document. For that reason, AngularJS provides a series of wrapper services that will help you to access these objects without hurting the testability of your application. First, we have the $window service, which is a direct reference to the browser window object. The same goes for the window.document object. The $document gives us a directive reference to it so we can access the document properties. Then we have the $interval and $timeout that are a reference to window set interval and window set timeout methods respectively. They work in a similar fashion to their global counterparts. Finally, one more service that is worth mentioning is the $log service. This one is a simple service for console login. The default implementation safely writes the message into the browser's console if present. The nature of the message will depend on which method you choose to use from the message types available. It can be a simple log message, an information message, a warning message, an error message, or a debug message. And that closes out our review of the services you need to know about. Of course, not all of AngularJS services were included on that list, just the ones you will probably need the most initially. With time and experience, you get to know Angular services better and will never need a reference again. In the next and final section, we're going to review AngularJS testability. We're going to learn a bit about test-driven development and the basics on how to perform both unit and end-to-end testing in AngularJS. I see you guys there. Hey guys! Now that we have covered the basics of AngularJS programming and that we know the fundamentals of application development using the framework, it is time to take a look at an important aspect we have been saving for last: testability. One of the fundamental reasons for choosing Angular is that it was designed and developed with automated testing in mind. Testing is a good approach to keep code maintainable, understandable, and bug-free. There are basically two different kinds of tests: unit tests and end-to-end tests, that are sometimes referred as integration tests. Those two are very different things which serve different needs, but you need them both. Unit testing is a technique that helps developers validate isolated pieces of code. They're isolated from the world to make it easy to simulate weird error conditions. End-to-end tests verify that all the pieces fit together. We're no longer talking about code here. This is automated interaction with the user interfaces, which for web means HTML in a browser. In other words, the unit tests are supposed to test your code. The end-to-end tests are supposed to ignore the code and test your application on a black box approach. AngularJS is compatible with many different tools to deal with unit and end-to-end tests. In this course, however, since we're just starting out, we're going to focus on the tools officially supported by the Angular team. Those tools are called Karma and Protractor, test runners for unit and end-to-end tests respectively. Both tools are compatible with the Jasmine framework. Jasmine is a behavior-driven development framework for testing JavaScript code. It has a clean, obvious syntax so that you can easily write tests. When written with Jasmine, both unit and end-to-end tests have similar anatomy. A test suite is comprised of one or more it blocks that describes the requirement of your application. It blocks are made of commands and expectations. Commands tell the test runner, either Karma or Protector, to do something with the application, such as run a specific function or click on a link. Expectations tell the test runner to verify and validate aspects about the application state, such as the value of a variable on scope or an input on screen. In addition to the above elements, tests may also contain helper functions to avoid duplicating code in the it blocks. Let's now take a look at unit and end-to-end tests separately. First, we have unit tests. The core units which make up features should be verified with accompanying unit tests. In JavaScript apps, the smallest units of code you can test are usually individual functions, like a function that adds a list of numbers together, or sorts a list of strings, or changes the state of a variable. From the user perspective, these units may be abstracted away from the app. They may even be unaware of this level of functionality happening on the background. Still, it's our job to verify that each of the chunks of our app work individually. Then, we get to the end-to-end tests. Unit tests are the first line of defense for catching bugs, but sometimes issues come up with integration between components which can't be captured in a unit test. End-to-end tests are made to find these problems. Because of that, Angular team built Protractor, an end-to-end test runner which simulates user interactions that will help you verify the health of your Angular application. Protractor is a Node.js program and runs end-to-end tests that are also written in Jasmine. Protractor uses WebDriver to control browsers and simulate user actions. In other words, it tests your application by running test scripts on top of the browser, exactly as a real user would execute the tests. When it comes to automated testing, there are two dominant approaches about how to write tests and when to write tests. The first approach is called test-driven development, or TDD. Test-driven development is a development process that relies on the repetition of a very short development cycle. First, you write an automated test case that defines a desired improvement or new function that will obviously fail since you didn't code the functionality yet. Then, you proceed to implement the expected behavior to make the test pass. The second approach is usually referred as test after development, or TAD, which is basically the opposite approach. Write your code first and then your tests. Despite being a great TDD enthusiast and advocate, I'm not here to preach about which approach is better for your needs. In this course, for example, we're going with the TAD approach because I think it's the best way to learn a framework, even considering TDD to be the best approach when it comes to a real-world development cycle. In the end, it all depends on the requirements of your project. In the next video, we're going practical and start writing unit tests to validate the application we developed on section 3. I see you guys there. Hey guys, it's time to go practical and perform some automated testing. In this video, we're going to retrieve the application we developed on section 3 and try to write a few unit tests for it, using the Jasmine framework. Of course, Jasmine is only one of many options you can take when choosing your testing framework. These options include Mocha, KUnit, and a few others. So our focus is going to be on how to configure our test runner and how to structure and run our test suites. The Angular seed boilerplate comes with Karma pre-configured for you, but the first thing we gotta do is go to the project root directory and open the file named karma.conf.js. This file contains a series of configuration variables your test runner will take into account when executing our unit tests. Let's take a look at one by one. First, we have the base path that is supposed to contain the path to your app in case it's not in the same folder of the configuration file. Then we have the files array. This one is supposed to contain every file in which your application depends on, including the AngularJS itself, the Angular route, Angular mocks, and any other component your application may depend on. In our case, we have one more component in the application, the Angular Bootstrap modules, so we have to add it as well. Let's go to our index, copy that, and paste it here. Then you gotta add the paths to all of the scripts of your app. We did not mess with the components folder, so this one stays as it is. We added some controllers and views, however, so let's change the file to reflect that. Let's add the files inside of the catalogs folder, the genres folder, and the movie folder. This will tell Karma to look for our scripts and our testing scripts inside of those folders. The naming convention for our test suite is actually quite simple. Let's say you have a script called catalog.js. The test suite for that script should be called catalog_test.js. This way, Karma will automatically know that it's supposed to run the test suites contained in the catalog_test file. The auto watch option tells Karma if it is supposed to keep watching your files for modifications and repeating the test suites when you make changes to it. Of course, that only happens when Karma is running. I'll get back to it when we try to run the tests. Then we got the frameworks, browsers, and plugins arrays. These ones are supposed to contain the testing frameworks, the browsers, and the Karma plugins that are supposed to be used by the test runner respectively. The last parameter, the JUnit reporter, is just some extra configuration needed by the Karma JUnit reporter plugin, responsible for logging our unit tests. Enough said about the configuration, let's go on and try to execute a test. But we don't have any tests here, so let's create one first. We can choose any component to test, so let's start by something simple. Let's go to Components, Paginate, and create a test file for our paginate filter. The paginate filter takes an array, a current page, and a page size as input, and returns the section of the array corresponding to the current page. To test it, let's create a test suite using the describe method. Let's call it unit tests for paginate filter. Then let's use the before each method to inject the moviedb.paginate filter module, since that's the one we want to test. Then let's create a mock array, let's call it element array, and it's just gonna be an array of numbers we're gonna use to test our filter. Now let's create a test scenario. We do that by creating an it statement and adding a description to it. Let's say this test should return only the elements on second page. Then we're going to inject our paginate filter, and let's create an expectation to confirm the test has passed. Let's say we use the paginate filter to filter the element array to return the elements in the second page, considering a page with 5 elements. And let's see how many elements it returns. Since the element array has 7 elements, the second page should return 2 elements, considering a page of 5 elements. So let's expect this element to be equal to 2. Now let's run our tests and see if we get the expected results. To do so, let's go to the console, navigate to the project directory, and run npm test. This will tell Karma to run our unit tests. It will also make a Chrome window pop up. If you check the console again, you're gonna see the tests were executed 1 of 1 with success. If you set the auto watch as true in the configuration file, this means Karma is going to watch your files, and if you make any modifications to your code, will automatically run the test suite. You can also ask Karma to do a single run of the tests and then exit. You can do that by using npm run test-single-run. Now that we know how to run our tests, let's try something more complicated. Let's write some tests to our movie service. First, let's create a movie service _test.js. Then let's open it and create a new test suite called unit tests for movie service. Again, we're gonna start out by injecting the module for each module moviedb movie service. Then let's create a couple of variables we're going to need. Let's call them movie factory and http mock. We're gonna use the movie factory to contain our factory and the http mock to contain the http backend object. We're gonna talk about it in a minute. Then let's create another before each block and let's inject 2 services. The movie API service we're going to test and the service called $HTTP backend. The HTTP backend service is a service exclusively crafted to help you dealing with HTTP calls on your tests. Since you have no way to be sure that the backend of your application will be reachable at the time you run the test, nor can you be sure about the content of the server response, you can use that service to fake a backend response with predetermined data. The HTTP backend service will intercept any HTTP call created during your test. Let's see an example. Let's just take our HTTP mock variable and assign an instance of the service. Then let's do HTTP mock when get JSON respond with something. What this will do is that whenever your service fires a GET call to that address, instead of responding with the actual file, the service will intercept the call and respond with anything you put here. In this case, let's respond with a mock array containing a single movie with a title, an ID, and a poster path. Then let's do the exact same thing to the genres. Let's copy paste, replace with genres, and instead of returning a movie, let's return a genre with ID, name, and a total, and that's enough. Now we are ready to actually create the tests. Let's assign the service to our variable movie factory. Let's create a couple other variables we're gonna use. Let's call it movie list and genre list that we're gonna use to compare. And then let's create a test case. Let's describe it as should retrieve the movie list when you use the getMovie function, obviously. So let's do it movie factory get movies, and in case of success we want the movie list to receive the data. Then we're gonna get the mock service and flush it. Flushing the HTTP backend service will resolve any asynchronous calls and make sure that the promises created by the HTTP service are resolved as well. Now we only need to compare the results. So let's expect the first movie from the movie list title to be movie title, because that's the title we provided in the mock object. For the getGenres function, we can copy paste that test case and do very few alterations. And this should do it. Now let's go back to our console and run the test suite again. It succeeded. And that's it. Now we have a test for our service. We should add some extra expectations to verify all the attributes, but I'll let that up to you. Now we can use that same knowledge to write some test suites for our controllers. I won't be detailing this process here, but you can find example test files for all 3 controllers we created on the code provided alongside this section. In the next video, we're going to review the process of writing end-to-end tests and running those with Protractor. I'll see you guys there. Hey guys, it's time to learn a bit about integration tests on AngularJS. We already know that the end-to-end test runner supported by the Angular team is called Protractor. Like Karma, Protractor has its own configuration file. On the Angular seed, you'll find it on the E2E tests folder, and the file is called protractor.conf.js. Luckily, we don't have to make any changes here this time. The specs array defines where Protractor should look for the test scripts. The browser name option defines which browser is supposed to be used by the WebDriver. The base URL defines what's the URL of your app on your local or remote server. The framework is self-explanatory. As we already mentioned, we're using the Jasmine framework for all of our examples. The remaining options are just timeout times for the execution of test cases. We define it in the specs array that all JS files on the same folder of the configuration file are valid test scripts. Angular seed comes with an example test script called scenarios.js. Let's open it up and take a look at how to write our first end-to-end test. Let's remove what we find here and create a new test suite called integration tests for MovieDB. Since the homepage of our app is the catalog, let's create another test suite called catalog as a child of the main test suite. And let's add some stuff. First, let's create a variable to hold an instance of Protractor. Let's just call it prot. And then before each scenario, we're gonna do prot gets Protractor get instance, and then browser.get/app. The Protractor instance will help us to deal with the browser. We're gonna check it out in a minute. And the browser get will make sure we redirect to the root of the application before each scenario. Now let's write a scenario. Let's write an it block, so it should render the catalog when user navigates to root. And to verify if it really happened, let's just add an expectation. Expect prot get current URL, that will get the current URL to match /hashtag. Now let's execute the test and see how it goes. Executing tests with Protractor is a little different from Karma. First, you need your web server to be already running when you execute the tests. So let's open a separate console window and run npm start to have our server up. Then Protractor depends on a tool called WebDriver that is used to control the browser and execute our actions. To install it, let's run npm run update WebDriver. After it's finished, we are ready to run our tests. Just do npm run Protractor. Chrome will pop up and your script will be executed. Pay attention to the fact that WebDriver depends on Java. So if you don't have Java installed, you probably got an error here. As we can see, Protractor worked and the test was successful. So let's write something else. For example, let's write a scenario to make sure that the user is redirected to the general list once he clicks on a general link on the right. Let's say it should take you to the general catalog when you click a link on the general list. And then let's create a variable called link and let's assign it an element selector by CSS list group item second child. As we can see in the catalog view, the objects with the class list group item correspond to the general links in the right. And we got the second element because the first one just redirects to all. Now we're gonna click that link with link.click. We're going to expect the current URL to match generous/action. Now let's go back to our console, let's try it again, and it worked. Let's get back and write a few extra tests. Let's open a separate test suite to test the movie details page. Let's describe movie and let's copy paste the before each here, but instead of directing to app, let's direct it to app #movie and the ID of one of the movies in our database. Now let's create a few scenarios. First, we must make sure the movie details page is rendered, so it should render the movie details page. Let's do that by checking if the div classed movie details is present on the page. So let's go back there, create a new variable called element, and let's assign it a selector by CSS movie details. Then we can create an expectation and use the protractor isElementPresent function to make sure the element is present on the page. And of course we expect it to be true. Now we can go back there and test it. Okay, let's add one more test case just for fun. Let's make sure the return to catalog button works on the movie details page. So let's create it block. Should take you back to the movie gallery when you click return to catalog. Then let's copy paste that to make it easier. And let's replace that with return-btn, which is the class of the return button. And let's expect the final URL to match just hashtag. We can save that, go back to the console and test it again. And that's it, now you're writing end-to-end tests. Of course, there is so much more to learn about Karma, Protractor and automated tests on AngularJS that this would be material for an entire separate course. For the time being, this should be enough for you to have a place to start and follow your own study program, depending on your expectations. I hope you liked the course and that it helped you to learn the fundamentals of that amazing framework. And of course, always keep an eye on Pack Publishing for my next video course. I'll see you guys there.